Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 234, Palindrome linked list. We're given the header of a singly linked list and we need to return true if it's a palindrome or false otherwise. So this is kind of similar to the string palindrome question, but now we've got a linked list instead of a string. So in this example, we've got 1, 2, 2, and 1, and when you reverse 1, 2, 2, 1, you also get 1, 2, 2, 1, so you return true because it's a palindrome. If you reverse 1 and 2, you get 2 and 1, which is not a palindrome, so you return false. And we're given some constraints. And we're told, can we do this in O of n time and O of 1 space? Well, we know it would be quite trivial to do it, to brute force this problem. All we'd have to do is go through each node, add it to a string, and then once we've converted our linked list into a string, reverse that string and check, does it read the same forwards and backwards? And if not, return false, otherwise return true. So that is quite the basic O of n time, but also O of n space. So we don't, although we can do it in this default, we want to kind of like look at the most optimal solution, doing it in O of n time, but O of 1 space complexity. So how can we do this? Well, you'd think we can, we could have a pointer at the left and a pointer at the right and basically compare the pointer at the beginning and the pointer at the end, and then keep converging the two pointers until they get to the midpoint. And if they get to the midpoint without either of the values on either side being different, then we can just return true. So that would be a simple solution. However, in a singly linked list, we can only move one way. So we can't have a pointer and then reverse that pointer. So we can have a right pointer, but we can't have a left pointer, basically. Also, we can have a left pointer, but we can't have a right pointer, which decrements. So how can we solve this problem? Well, if we look more closely at our problem, we can find like a little intuitive solution, and that is if we split our linked list into half. So we'll get 1, 2, 1, 2, and now we can compare. So actually we'll get 1, 2, 2, 1, and then if we flip our linked list, sorry, we'll get 1, 2, and 2, 1, and then if we flip 2 and 1, we get 1 and 2. Amazing. So all we have to do now is compare the values from either half together. So how can we solve this problem? Well, the first thing we need to do is find the midpoint of our linked list and then flip or reverse the second portion of our linked list and then compare the two values. So there's going to be 3 steps to this problem. So let's start with the first step, and that's finding the midpoint of our linked list. And we've done this in the previous video, but we can basically set slow equal to head and fast equal to head as well. And we're going to have basically 2 pointers, slow pointer and fast pointer. And we'll say while fast and fast.next, fast equals fast.next. So we shift the pointer 2 by right, and we shift our slow pointer only 1. So put a comment here, say find midpoint. So this is the midpoint of our linked list, and now we need to reverse second half. So now we need to reverse the second half of our linked list, and again we've done this before. So I would recommend actually doing questions like reverse linked list or finding midpoint, which will kind of help you solve the optimal solution for this question. So they're all just kind of like building blocks. So let's say while slow, well, we want to store slow.next in temporary variable. This is just basic reversing boilerplate right here. Slow is going to be equal to previous. Previous is going to be equal to slow.next is going to be equal to previous. Previous is going to be equal to slow, and then slow is going to be equal to the original slow.next. So now previous will be the new reversed midpoint. So basically we can imagine our linked list now looking like this: 1, 2, and 1, 2. So the two halves now look like this. And now all we need to do is compare the values. So we're going to say, let's actually, for ease of use, let's create a right and left pointer. We'll set our left pointer equal to our head. Our right pointer is going to be equal to our previous variable. We can't use slow because slow will now be none, but previous will be the last element in our linked list, or the last node in our linked list. So now what we need to do is say while we're not at the end of our linked list, so while we are in our second half still, we'll say if left.value does not equal our right.value. So let's put a comment here actually. Let's say compare to halves. Then we return false because now we know our linked list can't be palindrome. Otherwise, we'll say left equals left.next and slow, well actually, left equals left.next, right equals right.next. And if we finish comparing the two halves without returning false, well then we just need to return true. So let's run our code. And we get a non-time object has left.val does not equal to right.val. Okay, let's look at the code here. So, what fast.next, fast equals fast. Okay, slow equals slow.next. That might be the typo over here, the little error that we had. Fabulous. So now we pass the sample test cases. Let's check we pass submission. And we have quite an optimal solution. And we pass all 93 test cases. So, of course, in terms of time complexity, we're looking at an O of n, linear time complexity. But space complexity is the most optimal. It's O of 1. So, yeah, I hope you guys enjoyed this video and the explanation made sense. And I'll catch you in the next one.